A greywater system is a process designed where the greywater from a home is naturally cleansed by initially passing the water through a mechanical filter, in this case a gravel and sand filter, and then through a biological filter, in this case a reed bed. The resultant water is suitable for use in the garden and other non-potable uses. The idea is to build 5 greywater systems for owners of family gardens. At least 3 women, head of households, and 500 members of the 3 target communities. 3 in Barley, 1 in Bucomet, 1 in Chateau Belair fit use. Indirect beneficiaries include members of each participating family and the larger St. Vincent and the Grenadines population. Participants, skilled workers, and SVG's Central Water and Sewage Authority are key stakeholders alongside the Richmond Vale Academy. The objective of this documentary is to show the detailed construction of greywater systems. What are the benefits? Reducing the need for fresh water, saving on fresh water use can significantly reduce household water bills, but also has a broader community benefit in reducing demands on the public water supply. Reducing the amount of wastewater entering gutters, streams, rivers, sewers, and replacing the water that does leave the site with clean water, free from pathogens. Again, this can benefit the health of the individual household, but also the broader community. Provides clean water for growing crops, typically greens that are nutritious and easy to produce, given that they grow in water and benefit from easy access to soluble nutrients and lack of weed competition. Watercress, for instance, is the most nutritious green pound for pound in the world. This greywater system design is in 4 stages. First, the grease trap. Second, sand, gravel, and stone filler. 3, the reed bed. And 4, the productive green beds. The first stage, which is a grease trap. The purpose of the grease trap is to filter fats, oil, and greases from the wastewater early in the process so that the fog don't congeal and block up the pipes leading through the greywater system. As can be seen in the diagram below, there is a mesh filter placed before the kitchen wastewater, which enters the grease trap container to capture any food particles that are washed down the drain pipe. A 5-gallon cooking oil drum can be used for the grease trap. An opening is cut in the top of the cooking oil container to access the inside. The outlet pipe from the kitchen passes through a mesh filter before entering the standard outlet of the cooking oil container. An outlet hole is cut in the bottom of the cooking oil container and a bulkhead connector attached to it. This allows a 1.5-inch inverted constructed U-shaped PVC pipe to be connected as illustrated above. A second 1.5-inch hole is cut 2 mm above the waterline as depicted in the above illustration. A bulkhead connector is placed here and a 1.5-inch flexible pipe is attached. This takes the fog that floats to the top of the water down this pipe into a bucket that collects the fog. If the space above the waterline and below the outlet pipe is too great, then the fog will be permanently floating on the water, causing smell and creating undesirable conditions. The fog that collects can be added to compost or to animal feed as a supplement, 5% of total feed concentration. As the wastewater leaves the grease trap container's bottom outlet, there is a T-fitting with a valve to divert the water if necessary, away from the gray water system. This is for situations where it is necessary to perform maintenance on the gray water system without disturbing household water activities. The second stage, sand, gravel, stone filter. We can see in detail the distribution of sand, gravel, and stone in the drum. The wastewater leaving the grease trap enters a 55-gallon drum that has been cut approximately in half at the bottom of the drum and filters upwards through stones, gravel, and sand. The outlet pipe, as can be seen below, is placed approximately 2 centimeters above the top level of the sand. This ensures that there is always a layer of water covering the filter, which results in continual microbial decomposition of gray water constituents. A bulkhead connector will be required for the outlet pipe from the sand and gravel filter. The third stage, the reed bed. A reed bed is a natural filtration system that can be used to treat and improve water quality prior to use in irrigation systems and before discharging into the environment. It utilizes the ability of a reed to transport oxygen to the root zone, hence encouraging aerobic microorganisms to digest the contaminants in the effluent. The water leaving the sand and gravel filter enters a 55-gallon drum that has been cut lengthways so that its minimum depth is approximately 60 centimeters, which is 2 feet. This drum is filled with gravel and planted to a local reed variety. Water enters the reed bed at the base, see illustration below, and fills up the container to 5 centimeters, 2 inches, below the top of the gravel layer, where an outlet pipe takes the water and leads it to the fourth stage, which is the greens production. Bulkhead connectors are required for the inlet and outlet pipes for the reed bed. Finally, productive greens beds. The water leaving the reed bed can then be directed to a series of 55-gallon drums, which have been cut lengthways and filled 3/4 of the way up with gravels. The water level created by the outlet pipes in this series is 2.5 centimeters, which is 1 inch below the level of the gravel. Each household can start with 2 half-lengthways drums planted with watercress and kalu dashin respectively. See illustration above. The water leaving this series can go to banana circle, fruit trees, or continue to fill additional drums to the series for greater capacity. In conclusion, this method of recycling water is one of the best ways to use less clean water, saving water for irrigation, crop production. Gray water systems are becoming more and more popular worldwide, especially in countries experiencing droughts or water shortages.